How many of these electrical components can you name just by looking at their symbol? Pause the video and see how many you get. Now, before we go through them, it's really important, before we look at the topic of electrical circuits, we're going to look at the basics today, including circuit components and what they do and how to use them in a circuit. So let's dive in. First one, should be easy peasy, is a bulb slash lamp. Now that emits light, obviously. A switch allows us to either prevent current flowing or it allows us to allow current to flow. So either stops current or allows it to flow. Now, the next two look very similar. If it's one of the short line and long line, it's a cell. If it's two of them or more, it's a battery. They have the same purpose. They provide potential difference and therefore energy to the circuit. The A with a circle around it is an ammeter. It measures current. More on that later. A voltmeter measures potential difference or voltage. Same thing. The box with a line either side of it is a resistor. A resistor restricts the flow of current. How it does that, you'll have to wait for the next video to find out. Now, the next one down has an arrow flowing through it. This is a variable resistor. It does the same thing, but it allows us to change the resistance if we want to. Bottom one is a fuse. More on that in the mains electricity topic. Now, there are a couple of extra ones you need to know as well. A play button with a line next to it is the symbol for a diode. Now, a diode is like a heart valve from biology. It allows current to flow in one direction only. There's another version of this. It's called a light emitting diode. Now, it's the same symbol with two arrows coming off it, and it's commonly referred to as an LED. You'd find them in the little red light in front of your TVs and lots of electrical devices. They emit light and also, same as a regular diode, allow current to flow in one direction only. The next two are possibly the hardest to remember. So if you have a little rectangle with two arrows going towards it, it's not an LED, it is an LDR, which stands for light dependent resistor. So there's a resistor that depends on the light. The similar component to it is this one here. It's called a thermistor. If you squint a little bit, you can kind of think it looks like a backwards T. So you can learn it that way. Now, if you want to know more information about the bulbs or diodes or resistor and their characteristics, you need to watch my video about the required practical. But let's have a look at these last two components first. Now, on LDR, resistance will reduce when light is increased. So more light means less resistance. A thermistor, as the name suggests, is to do with heat, and this one will reduce resistance when heat increases or when it is in a hotter environment. Now, not a linear decrease, it's a decrease that's a curve, so the resistance on the y-axis, and for a thermistor, it's temperature on the x-axis, and LDR, it's light on the x-axis, will decrease in a curve. So where are they going to be used? You'll find thermistors used in thermostats in your house to control when central heating comes on. An LDR you'll find in street lamps or floodlights to determine when they come on when it gets dark. Now, how do we draw a circuit? Here's a simple circuit here. It is really important that we use straight lines, pencil and ruler, even though I haven't used a ruler here. And we are only drawing the circuit symbols. We are not trying to sketch out a light bulb. We use symbols. Now, ammeters and voltmeters come up a lot, so make sure you know where to draw them. An ammeter we draw in series or in line with the components. A voltmeter we draw in parallel or essentially across or around a component. The reason is it measures the potential difference before and after. Now, another really important thing about circuits is something called conventional current, which is which way the current flows. Now, convention suggests it goes positive to negative, which means from the long end of the battery to the short end. However, it doesn't actually flow this way, but it's an assumption we make when we draw certain component symbols. Like, for example, a diode, the play button has to be pointing in the direction the current is flowing, just like in this example here. So please tune into my next video where we're going to look at a bit more detail at these components, in particular how do series and parallel circuits work.